All right, everybody, welcome to this slightly less last-minute scheduled virtual office hour. Still think I need to come up with a slightly different name for these episodic, event-driven one. I've been calling them pop-ups, but maybe I need to formalize that. In any case, welcome to this session, which will hopefully be a little less frenetic and also shorter than yesterday's multiple live streams. Thanks, folks, for joining me in the midst of things. Those always tend to be well-attended sessions when events are unfolding in real time, and there are still some events unfolding today. Of course, everything that happened yesterday did not suddenly disappear overnight. In fact, there were many new wildfire ignitions overnight, on the order of dozens, from the thunderstorms that continued, particularly in the northern Sierra. But these were wetter storms than the initial storms yesterday, and so the fires that they have ignited are more of the holdover variety. So these are not wildfires that become that arise instantly. The lightning strikes the tree, it bursts into flames, and it immediately starts spreading. A lot of these fires are fires they're sort of a lagged response. That's what these holdovers are, where there may be lightning strikes a tree, a living tree perhaps, or maybe a dead tree known as a snag, or something else on the landscape that's somewhat flammable, but also somewhat insulated, and it's raining, say, during the thunderstorm, which we did see with more of the storms later at night, last night, and that tree, living or dead, might burn on the inside, so the lightning's hot enough to instantaneously cause a flashover, and that tree starts burning, or at least smoldering. But there's rain, and the outside of the tree trunk or the ground around the tree gets wet, and so obviously wet organic material is not nearly as flammable. But that tree, that trunk, that stump, that log on the forest floor, whatever it might be, smolders for 6, 12, 24, sometimes even 48 hours, or even rarely longer than that. And the storm moves on, the sun comes up the next day or the day after that, it warms up, it dries out. Those holdover, smoldering ignitions can come to life. They burst into flames, smoldering combustion becomes flaming combustion, and then you're off to the races. We've seen that today with a number of fires that have transitioned from smoldering to open flame, on the order of a couple dozen new fires. The good news is that at this point, none of the new ones, none of the holdover fires today are particularly threatening to communities at this time. That could change, but right now, none of the new ones today are nearly as immediately community threatening as many of the initial dry lightning ignited fires were yesterday. And so I will talk a little bit more about those newer holdover fires later in the session, but I did also want to step back and talk about what's already transpired. From Monday night into Tuesday morning, thousands of dry lightning strikes occurred over set portions of central and northern California. This was a really prolific lightning event. The kind of which we do not see every year. In fact, we would typically only see a lightning event like that. It's difficult to measure. We don't have a great record of this, but I would estimate in the part of the state that experienced it, every 5 or 10 years, we get a lightning event like that, where there's a significant dry lightning component, where there's little precipitation, where there are thousands of distinct lightning strikes. So it was an unusual but not an unprecedented event in that capacity. Now, no two events are the same. Have we ever seen an event exactly like that before? Probably not, but you get the idea. This is, by the way, the time of year when dry lightning is most likely in California, late summer, early fall, and also most consequential, usually, because it's the time of year when vegetation reaches its peak seasonal dryness. And in this case, we had a significant and prolonged heat wave, not really record-breaking, but a significant heat wave immediately preceding this dry lightning event, which really dried out the landscape to its maximal level so far this season in many places. It's also the case that a good portion of central and southern California has been experiencing drought conditions. Now, Notably, and quite fortuitously, the northern third of the state is not really experiencing drought of any meaningful severity this year. And that makes this is part of the reason why this event was so different from the 2020, the catastrophic wildfire outbreak that resulted from that incredibly extreme dry lightning event. Now, that event was different in multiple respects. One is the thunderstorms in general were much stronger during that event. They were actually quite severe storms. They brought very strong winds of 60 to 80 miles an hour in some places, although we did locally see that, by the way, early Tuesday morning in some places like the eastern Sacramento suburbs, as I discussed yesterday. But the storms in 2020, the dry thunderstorms then, they produced an even greater volume of lightning, on the order of tens of thousands of lightning strikes. And it also occurred over a part of California that is much more vulnerable to lightning ignitions that go on to become large fires. There were dozens, if not hundreds, of fire ignitions on Tuesday due to lightning in California. Literally, probably, I'm almost certain, in fact I am certain, there were more than 100, and it was probably in the multiple hundreds of fires ignited. But the vast majority of those fires were relatively small and inconsequential. I would say probably 70, 80, maybe even 90% of those fires were a single tree or a quarter, half acre of grass and brush surrounding a tree or something. That were either naturally self-extinguished by rain or were quickly extinguished by fire crews. Sometimes those fires are small enough that if you get lucky, you can essentially extinguish them with a single well-aimed bucket drop from a helicopter with water. So if you catch them when they're that small, one helicopter bucket of water can do a lot of work. And that did happen. There were a lot of good catches yesterday. But part of that, again, contrasting with 2020, occurred because the vast majority of the dry lightning, these prolific thunderstorms that produced hundreds or thousands of lightning strikes and little, if any, rain, occurred mainly over the Central Valley. These occurred over the flatlands, the cities, the irrigated agricultural fields, and some of the more open natural grasslands that remain in the Central Valley and the lower foothills ringing them in California. This dry lightning mainly occurred there. So instead of occurring over the rugged coastal mountains in California, which are home to diverse ecosystems, but most prominently heavy forest and heavy brush, that are topographically complex with relatively sparse road networks, few people around, less availability of ground-based firefighting resources, and just much denser, heavier fuel. We didn't see most of the lightning occur in those settings this time. It mostly occurred in the flat valley. So the topography's flat, there's more people, there's a good road network, a lot of the vegetation is literally irrigated and largely resistant to burning. But finally, even in the places where that was not true, a lot of what burned was grassland. And you can get large, potentially destructive wildfires in grassland ecosystems, but you can also, for the most part, you can control grass fires more easily than you can fires burning in much heavier fuels and brush, or especially in heavily forested regions when there's a high intensity fire. You can have flames that are 100, 200 feet tall. You can imagine that even a big bucket of water from a helicopter is going to do really essentially nothing against a wall of flame that's 100 or 200 feet tall. But a grass fire, anybody who's ever been around a prescribed fire, you can, if you're wearing cotton clothing, you can essentially step over a low intensity grass fire under the right. Don't try this at home, but in general, this is not something that's this immense wall of flame that's incinerating everything. It's actually, you wouldn't want to stand in front of a wind-driven grass fire, don't get me wrong, but in general, the amount of thermal energy that grass fire is putting out per acre burned is a whole lot less than an acre of timber. And so for that reason, it's potentially easier to extinguish fires in those settings. So it's easier to directly, the traditional thing of putting water on flames works pretty well if you can get water onto the flank of a grass fire. Building fire breaks is often simpler in the sense that if you're in a flat grassland area, it's pretty easy to drive a bulldozer through there or some other piece of heavy equipment, build a pretty effective fire line pretty quickly. And also, when the winds die down, those grass fires are going to spread in a flat, grassy ecosystem. They're going to spread in an almost uniform radial direction at a slow rate of speed. So you can get really fast-moving grass fires, but usually it requires either a steep slope or strong wind. You can get pretty fast-moving forest fires sometimes just by by virtue of their own intensity. They sort of tend to create a faster forward propagation speed. So all of those things, grass fires usually are easier to either directly extinguish or indirectly extinguish by directly applying water or fire retardant, or by starving them of fuel, by cutting fuel breaks, which again is much easier usually in grass than in a forest, for example. And so a lot of the fires that started yesterday from these thunderstorms were burning primarily in grass. Some of them got pretty big. We had some 5 and even 10,000 acre grass fires, so those are pretty large grass fires by California standards, but they're not nearly as consequential as long as they stay away from structures as a 10,000 acre fire in the timber would be. That's going to release a lot of carbon, and if it burns at a high intensity, which it probably would have under the conditions yesterday, that's potentially going to cause a lot of ecological disruption if it's a uniform high-intensity burn. But grasslands usually recover well from fire. They're fire-adapted in most cases. Fires are easier to extinguish there. The grass will be back next year in most of those places, next time we have a rainy season. And once the winds die down, which they eventually did, it becomes really easy with the kind of firefighting and air support resources that CAL FIRE has at its disposal. Once you have a grass fire burning under lighter wind conditions, CAL FIRE crew can make pretty quick work of that in most cases, which is exactly what happened in most cases, except in those initial hours when there were very strong outflow winds from these thunderstorms, which means two things. One, the winds themselves are going to push grass quickly, so the only downside of grass fires as opposed to, say, a forest fire is they can be very responsive to winds. You can have a grass fire that's just smoldering around, not doing much, and then you put a wind on it and it can stand up and run a mile or two over the course of just a few hours as soon as that wind picks up. It usually takes, you need a little bit more momentum, a little more time in those forest settings to build up that head of steam and to the same degree. But once that wind died down, it was easier to manage. But part of the problem was when the thunderstorms were around, you can't fly aircraft in some cases because it's not safe for fixed-wing aircraft to fly inside a thunderstorm at a low altitude with a lot of turbulence, erratic gusty winds, microbursts and downbursts. Think of that downburst in East Sacramento suburbs. You wouldn't want to be flying 500 feet off the deck trying to do a retardant run on the slope of a mountain if you get hit by a 70-mile-an-hour downburst. So that's why we don't see those aircraft flying under those conditions. Also, you tend to have, when you're trying to drop either fire retardant from a fixed-wing aircraft or even water from a helicopter, it just isn't as effective when it's that windy. As you might imagine, it disperses over so wide an area that you kind of lose the concentrated effect of either sort of building up a linear feature, a fire line with the retardant along a ridge line or another, a road or a river or some feature that you want to sort of enhance as a fuel break, or by dropping water directly on flames or smoldering material. You just kind of disperse the water. So air support's less effective, as you've talked about before, when it's windy, and it was very windy locally yesterday because of the thunderstorms, not because of some large-scale storm system, but in isolated and regional pockets, erratic gusty winds. And there were also so many fires. As I mentioned, there were dozens. Probably a number of these went unreported and were handled by local fire crews, didn't make it onto watch duty. There were probably hundreds of individual fire ignitions, everything from people's chimneys being struck to individual trees to bales of hay and who knows what else bursting into flames and being extinguished pretty quickly by local fire crews. But that does mean that you have to pick and choose, and you can't send an all-out response to every single individual ignition because there's only so many fire crews to go around. You want to try and at least be able to send one engine or one crew to every event if you can, So you start to triage which of the events appear to be taking off initially or not, which ones appear to be kind of just skunking around, which of them are close to assets at risk, structures, or infrastructure, or and sometimes something that factors into the calculus is, well, this one doesn't look too bad right now, but if it picks up in intensity, or if the expected weather conditions come to fruition, is this going to be a dangerous fire based on where it is, what fuels are around, its proximity to communities, and where it is in geographic relation to all of those things based on where the winds are going to be coming from later, things like that. So all of that enters into the calculus. Obviously, there's no one-size-fits-all optimization formula. There are semi-standardized operational tactics, but a lot of this is ad hoc because you're operating literally in the fog or the smoke of what feels like a campaign in a war, because you don't know what's going on the ground. You literally can't see what's going on in some cases because of smoke or storms or darkness. This is where the alert cam, the fire camera network, has come in handy. A lot of these initial good stops yesterday occurred because either fire operations folks or other people saw initial starts, just individual trees smoking or on fire after being struck by lightning. You're able to pinpoint it on the camera view, and you can send a crew there quickly, potentially. Now, if it's a remote place, it's going to take a few hours to get a ground crew in. Maybe you're lucky and there's a helicopter available to fly and it can get there in 20 or 30 minutes. But for that first 10, 20, 30 minutes, that fire is going to do what it's going to do in a situation like this. And in a few cases, that was enough for these, just a tiny handful of the initial ignitions to really take off in a big way. And the one that really did so in a way that caused the most harm, I think, in this case, and I need to make sure I'm actually remembering which of these fires it was, because a lot of these have numerical names rather than place-based names. It makes it a little harder to remember. Yeah, this is the 6-5 fire. It's about a 7,000-acre fire, and it started not far from the shores of Don Pedro Reservoir. And it burned under really strong, gusty thunderstorm winds to the north. And unfortunately, it did, in fact, burn into the community of Chinese Camp, so named for its history in California. And contrary to some initial reporting, Chinese Camp is not a ghost town. It's definitely a depopulated town relative to its population peak, which I believe was around 5,000 or 6,000. Back when it did house laborers, but there are still, at a minimum, it's unclear from the current census exactly how many people still live there, but it's somewhere between dozens and hundreds, depending on how you measure tenancy versus residency. But the key point is this: that community was largely wiped out by this fire, and that involves a lot of historical structures, but critically, places where people today still lived. And so this was another significant loss. It's a small community, but it's still a real loss. And so there was significant structural loss in that community. I don't know if there's been any official reporting on it, but it does sound like, unfortunately, a majority of the structures and the infrastructure in the community did burn. So that is yet another small California town that has been largely destroyed by a wildfire. And this year, except for the catastrophic events in Southern California, so that is a very large exception, the traditional fire season months have not seen, as far as I can recall, any significant structural loss. There have been a couple of fires that burned 1, 2, 3 structures, but generally speaking, the degree of structural loss this year after January, which again, those were some of the largest structural loss events on records with the Palisades and Eaton fires, was pretty low relative to acreage burned. That has changed a bit. Now, relative to the multi-thousand structures lost in some of the worst recent wildfires, this won't compare because the community just isn't that large to begin with. But it is still a significant loss. To my understanding, there was minimal structural loss yesterday on the rest of the fires. I don't know the official accounting, but that was the main one where there was significant structural loss. There were other fires that seriously threatened communities. In fact, another 6 numbered fire. I'm just looking at the map here. It was the 2-7 fire south of Murphy's. It's still burning. There's still evacuations for part of Murphy's, but it looks like that one is largely a done deal. So the evacuations at this point are mostly precautionary, which is the good news, because that one made a beeline right for a populated corridor along the Highway 4 corridor, and that could have taken out a good portion of a still small but larger than Chinese camp, the town of Murphy's and surrounding subdivisions. So fortunately, to my understanding, that did not happen, and the structural loss on this fire was minimal or potentially even zero. I don't know. So that was an incredible catch. That could have gone the same way of Chinese camp, but for some really good firefighting and some good luck, that the erratic thunderstorm winds didn't push in a different direction than they did. So there were other fires yesterday, and again, I think around 30 to 35,000 cumulative acres burned from fires that started just yesterday. So that's actually not a small number, given now. Again, we've seen other days in recent California history where a far greater number of acres have burned, but given that we were sort of starting from scratch in a lot of ways, that's quite a lot, and that was in the form of dozens of multi-hundred acre or multi-thousand acre fires that burned almost exclusively ignited by lightning. So that significantly bumps up California's acreage burn total for the year. And, as I mentioned, there are a bunch of new holdover fires popping up now. In fact, I would expect that when I start sharing watch duty in a minute on screen, that some of these, there'll be yet new fires since I opened the app 20 minutes ago. Because, again, the residual effects of lightning are going to continue to pop up for at least another day or two. And there could be some isolated storms later this afternoon, again, that could result in yet more holdovers to come. There is that yesterday's system, by the way, has now moved into Oregon, where it's generating a big lightning event up in Oregon now, which is experiencing a more significant recent heat wave than did California. So there will likely be further ignitions up there. And the wildfire situation in Washington, and in particular British Columbia, is pretty serious right now. And I'll show some data on that in a moment. So, thanks for the support, folks. It's always appreciated. I see that coming in through the chat. I'm going to take a moment to take a look at the questions we've gotten so far, and then I'm going to transition over to showing, well, a bunch of stuff on screen. And this will, again, include watch duty, weather radar, since there is some stuff to talk about still, especially satellite. Today's a big satellite day, and also some weather model data, because there is some good news. There's some mixed news, but there's also some good news in the forecast to come. So I will be talking about all of those things in just a moment. So let's see what we've got here. And I will mention, by the way, that it is really helpful when folks share these broadcasts while they're live. I'm pretty sure the YouTube algorithm likes contemporaneous sharing a lot more than after the fact sharing. So I always forget to mention that until the end of the session. This time I've remembered slightly before the halfway point, while it's before it's moot. Well, there's a question from Jay, and that is whether the indigenous peoples of California set fires for any particular reason, and if so, how the fires were controlled, if at all. So, to be clear, I'm not an indigenous person, and I don't necessarily study indigenous practices personally, but I am familiar with both the natural history and the indigenous history of fire in California and the American West. And yes, the short answer is yes, that indigenous peoples all around the world, by the way, and pretty much every continent, there's some history of purpose-driven burning of landscapes. And depending on which culture and what context, the reasons vary. There are cultural reasons. There also are practical reasons, and there isn't always a distinction between those two things in a lot of these settings. But there was active land management for millennia in places including what is now California, but also throughout what is now the American West and Canadian West, and really everywhere else where we have these histories that have been related to us. There are, for different reasons, convergence of cultural burning across cultures and societies over many millennia, and in fact, that has shaped the ecology, the present day ecology of places like the American West today and California. And in fact, it is only in the last century or so that equilibrium from millennia of extensive, sometimes quite extensive, cultural burning has shifted again with our 20th and 21st century, really 19th, 20th, and now 21st century suppression of both natural and cultural burning. So we have, in places like the American West, the last 150 years or so, suppressed a lot of both the natural fires, which mainly would have been lightning caused, like the ones we're seeing this week, and also indigenous and cultural burning practices. And this is true not just in the U.S., it's been true in Canada, it's been true in Australia. There's been movements, in many cases successful movements, to try and reinvigorate that cultural and indigenous burning. But really the point I want to make in this context, again, acknowledging I'm not an indigenous scholar in any form, is that this was a first order control on the landscape for millennia in these places. This was essentially, these practices exerted a very large scale influence on what the landscapes looked like by all accounts. And in some cases that means that, for example, forests had much lower tree density than they do today in a lot of the American West in their pre-settlement form, back when there were relatively regular lightning-sparked fires naturally, kind of stochastically, randomly across the landscape, and more targeted cultural burns. And there were some, in some cases, specific practical purposes. Fire is a restorative process. Sometimes the process of burning and then having deposition of ash can fertilize the soil. So obviously that's desirable either if you're cultivating plants or if you're relying on natural regeneration of healthy shrubs or food-bearing plants of any kind, or textile plants that are useful for any number of textile-related purposes. It also potentially increased the degree of visibility of game in wooded areas, for example, if you have fewer trees per acre or less accumulation of brush. So it creates open areas and clearings and keeps the landscape more of a patchwork. And it probably did, in many cases, reduce the risk of catastrophic unwanted fires when natural fires got close to where people were. It gives you a bit of a natural fire break where the intensity of a fire decreases. That's something that we are sort of relearning now, right, with prescribed fire and with all these conversations about how to reduce the risks. So that's certainly not a comprehensive view, but it is an indication that we're living in a world that actually looks pretty different in the American West than it would have even just a few hundred years ago, because the fire regimes have changed a lot. And this is, sometimes you hear folks who are either misinformed or trying to misinform. I've seen both sides of this, who will point out that a few hundred years ago there was probably a lot more fire on the landscape in a lot of the American West and California than there is today, and say, oh, global warming can't be changing anything, or forest management practices and timber practices can't possibly matter. Well, the problem is that's just not true. They do matter. All of these things are relevant, and none of them exist in a bubble. We do have climate change. It is making the problem worse. But we do also have the legacy of suppressing a lot of these fires, especially in forested ecosystems. And then I know the folks who focus on chaparral will point out that we have perhaps too frequent fire in some of these brushy chaparral regimes in Southern California. So these shrublands, these coastal shrublands perhaps, have too much fire. So we've altered that fire regime in the opposite direction, that we've altered the fire regime in some of the coniferous forests. But now the challenge is all of this exists in a world where we do have communities with thousands or even millions of people living in them, in these crowded, fire-prone landscapes. We also have a climate that is a lot warmer and an atmosphere that's a lot thirstier than it used to be. And that affects both of these things because we had for millennia a relatively stable climate. That's the other thing that's different from hundreds or thousands of years ago, is our climate today is already very different than it was for millennia before. And so all of the human interactions with the landscape, all of the natural processes that have evolved since time immemorial, they're all unfolding in a different background context than they used to. And so we can certainly learn lessons from all of this. We also have to acknowledge that today is very different from 50 or 100 years ago, and especially very different from a couple hundred years ago. And there's a lot of different moving parts here. The climate is warmer, there's more people living in higher risk places than ever before, and we've also made a lot of choices about what we say that people can and can't do, in what fires can and can't do, the degree to which we suppress them. That's affected all of this. The other interesting thing I would point out in this context before moving on, but I think it's a constructive tangent, so thank you for asking the question, is that, and I've talked about this before, and this is a bit of a personal, professional hypothesis, but I think we are seeing it borne out in the data, and it would be an interesting study to run, although a difficult one, which is that post-2015, or really post-2020, let's say, in California really got serious about aggressive wildfire suppression. So to its credit, CAL FIRE is now probably the world's leading entity in wild and firefighting and suppression. They're second to none in the ability to rapidly respond to fire-related emergencies, and their primary goal, of course, is to save life and property, but do so by extinguishing and containing fires. That's kind of the job. And we definitely need an agency that's capable of doing that. Nobody's arguing to abolish the fire department in this case. But the point I'm trying to make here is that the better we get at suppressing some of these fires, unless we are somehow reintroducing fire in some other form on the landscape, prescribed fire, cultural burning, for example, then what we're doing is just perpetuating this problem of the fire deficit in a lot of these western forests. And so if they don't burn when these fires ignite, either by lightning or by some human cause or something else, then what we're not doing is solving this underlying problem of these forests lacking their needed fire history, lacking that natural clearing of the underbrush or the partial culling of trees so that the ones that survive create a healthier, less flammable environment that's closer to what it would have looked like a few hundred years ago. The problem with aggressively suppressing every single fire is that unless we scale up those other kinds of fire, prescribed fire, traditional burning, at a similar pace that the natural fires want to burn the landscape, then we're actually just having this increasing divergence between, on that side of the problem, between what we actually need to be doing, which is embracing beneficial fire in the landscape, but trying to avoid as much harmful fire as possible. We're getting really good at trying to suppress the fires we think are going to be harmful, but we're maybe not scaling up our ambitions on the other side of that coin nearly as much. And so what's happening, I think, is that we're getting really good at putting out fires under mild and moderate burning conditions. We've seen that this summer, we've seen that in recent summers, where there's a lot of good stops. And I think a lot of them, maybe most of them, are objectively good stops. You don't want a massive wild and urban interface fire in Auburn or in the Oakland Hills or in the foothills above LA, which unfortunately we were not able to successfully suppress that one back in January. So clearly there are some fires we do not want to happen, especially under extreme wind conditions. That's just bad news, right? But there probably are some of these fires we do want to happen, and it's not always clear from the outset which is which, because you can transition from one to the other. You can have a fire that begins out as a nice low to moderate intensity understory burn over a couple hundred acres, and then you get a wind event, it changes direction, and then burns 20,000 acres running toward a major populated area. That's no good. But the reverse can also be true. Some of the most destructive fires in California history, I'm not quite sure if that cut out, by the way, but so I just wanted to make sure, sorry, I cut out mid-thought on my end. Not 100% sure if I cut out on your end, but I'm just pausing my speaking just to make sure that nothing gets lost in the meantime. But just to complete that thought, I think I have too many browser tabs open, by the way. That's a perpetual problem. But just to complete that thought, you can have initially beneficial fires that go on to become harmful when conditions change, but you can also have initially harmful fires that become beneficial when conditions change as well. So some of the fires that have been most destructive in recent California history have been really destructive and harmful in their initial hours, and then go on to do a lot of what we could call good fire work in the days after, when it slows down. So it's a complex picture where we do want to have a wildland firefighting force in California that can rapidly respond to wildfire emergencies. Yesterday's a great example of where that really comes in handy. I'm pretty sure there's communities that were saved yesterday that might not have been saved with the Cal Fire of 20 or 30 years ago. I think that's can't prove it, but I have a feeling that was probably the case. But also, it's difficult to pick and choose, because there also were probably a fair number of fires that would have burned yesterday without aggressive suppression that could have done some of that needed beneficial burning in some of these ecosystems. So how do we balance that? If we're getting really good at suppressing fires under mild to moderate conditions, but we still see catastrophes like what happened in LA this year, then clearly we haven't conquered fire in its most extreme form, which is the one that's the most problematic, that I think everybody can agree we want to suppress fires that have the potential to burn 30,000 structures or 20,000 structures. But how do you determine which is which? And how do you ensure that by suppressing the ones that you're really scared of, you don't suppress your way into an even worse situation as the climate continues to warm and as we continue to have more people living in harm's way? I'm not going to solve it during this live stream, but it's a complex situation I think is always worth emphasizing and re-emphasizing, because often you get really overly simplified sound bites. One of the things I like about these live streams is I can go along and have a longer form conversation for those who are willing to sit here for an hour, or at least anyone who wants to clip the 30-second version is always free to do so with this and any other content, by the way. It's one of the reasons why I do these things. So a little bit of a tangent, but again, I think this was a healthy conversation. Okay, so I'm going to share some stuff, and then I will come back at the end and answer whatever questions remain, since I know I've spoken a lot today, and I do want to show some stuff on screen. So let me do that by sharing the screen, and just give me a moment here. Yep, that's what I want. Sorry. It's been another long day. So what you should be seeing full screen is a satellite loop. So this is the Goes West satellite, current live view looking down over California and western states in general. And one thing that's nice to see is that there's actually less smoke today than there was yesterday overall, which is I'm actually a little bit surprised by, but I think a lot of the smoke got blown east last night, so that's part of it. And the other thing is that there's much less active thunderstorm activity. There's still isolated storms along the crest, a couple down in Southern California over by east of Death Valley, and there's also some ones swirling up in Oregon. I'll zoom in on that later. You also see that fog has returned to the north coast, but the coast is mostly clear from the Bay Area southward, although the fog looks like it's now rolling into San Francisco, or maybe Monterey Bay more so. But in any case, not a bad day out there in a lot of California, although we're going to zoom in and there is going to be some smoke around. But let me go north first, take a look at Oregon. So remember that low pressure system that yesterday was just off of San Francisco? Well, here it is now, and it did make it inland over southwest Oregon. And how I mentioned that we narrowly missed an even wider dry thunderstorm outbreak across California, including the Bay Area? Well, This is why. Had this storm been a little bit delayed over California, this is what we could have seen over the Bay Area. And this is a cluster of pretty strong thunderstorms that at this point are only about 5 or 10 miles from the coast. And these have ignited multiple fires today. So I'll show that on radar as well. But it is a pretty interesting view, because if I'm going to zoom out again, and you see this over the Pacific Northwest, this low pressure system over Oregon, it's driving a pretty significant thunderstorm outbreak over northern Oregon, so this includes the Portland area later this afternoon as well, maybe right around now, the Willamette Valley, the I-5 corridor. And look at some of these fires, this huge pyrocumulonimbus cloud in Washington state, but look at all of these individual fires up in British Columbia, eastern Washington, northern Idaho, southwestern Montana, even central Oregon. I'm going to go a bit farther north still, and what we're going to see is, and just give me a second here to close the door fully. Just to avoid some background noise. Drifted open in the breeze. I'm going to go up, show what's going on in British Columbia, because as I mentioned, British Columbia is experiencing an all-time September record-breaking heat wave this week that is being attenuated only by the enormous volume of wildfire smoke that is blocking out the sky, especially in some more remote interior parts of British Columbia. And if I go over to the shortwave infrared, which is going to give you a sense of wildfires, each of those black dots in BC is a large wildfire, but also look at the black dots in northern Washington as well. There is a lot of fire on the ground for this time of year right now, and it's all coming to a head during what is literally it is literally the hottest day ever in September in southern British Columbia. We've never seen a hotter day. Same thing is true, by the way, in eastern Washington. It's not record hot in Seattle, but east of the Cascades, this is again essentially the hottest September day we've ever seen. And if you want proof, by the way, that this is pyrocumulonimbus, look at what that looks like with the infrared satellite. You see the black dot, which is the fire, and you see this white plume emanating out of it, which means that the top of the plume is so cold that it's registering at the same height as the top of thunderstorms. So that is a classic pyrocumulonimbus cloud. But also look at everything else that's going on in terms of the fires. We have these hot spots in northwestern California. Those are lightning fires from a couple of weeks ago. We have this fire in central Oregon. We have this huge fire southwest Washington. We have all these other fires in this region right now where there's black dots. So there's a lot of fire activity. In fact, a lot of it is even more significant outside of California right now. And this low pressure system is going to continue to drag thunderstorms that are going to cause these fires to blow up in a hot and dry air mass, but also with lightning and strong gusty winds. So the peak of this fire wave up in the Pacific Northwest in BC is today, but maybe even the next couple of days. Hasn't even happened yet. Hasn't even peaked yet, I should say. That pyrocumulonimbus in Washington is so interesting. I'm actually going to zoom in on it just for a moment because, well, it keeps getting split. Okay, this is the right view, so it's in the lower left. You can just see it's really just an enormous plume of smoke. But look how many other fires there are. I mean, these are all producing large pyrocumulus trending towards pyrocumulonimbus clouds. There's just fire after fire after fire after fire after fire after fire, just to give you the idea. Okay, so I'm going to show temperatures. Let me refresh this. The cool weather record-breaking temperature log is back up, by the way. So you can see no records, of course, today in California. It's cooling down, but up in the Pacific Northwest and BC, lots of places breaking records. And what does this look like in general? Well, Haines, Alaska, for example, tying the all-time record monthly high and still warming. The interior, Omak, Washington, breaking a monthly record by at least 4 degrees. Burns Lake, BC, breaking the monthly record there too. Elk Valley in Canada, breaking by a couple of degrees. Cranbrook, Cranbrook, BC. That's another at least tying the September record. So you can kind of see this. And then, Yakima, Washington, Spokane, and some places in southeastern Alaska, notably Lytton, up around 100 degrees. A lot of these places still getting warmer. So monthly records broken in eastern Washington and BC. Again today, some of these were monthly records that were set. Checks the calendar here just yesterday or the day before. Okay, so let's hop over to watch duty, see what's going on in California. So I have all the fancy advanced features turned on today because sometimes I forget to log in. Again, Southern California less active. There have been a couple of fires today, but I'm not going to focus on those. I'm going to go from south to north. I'm actually going to zoom out first to the whole west. So there's a lot of fire activity. The purple things are essentially firefighting aircraft, either helicopters or fixed wing, rotary wing or fixed wing. I want to draw something. I'm going to draw a little polygon like this. Can you guess where there's recently been heavy monsoonal rain? Well, it's in this region where there's now fewer fires or mostly extinguished fires, as you can see here. It also happens to be a desert and Great Basin region, so there's not as much vegetation to burn as the outside of the ring, but you get the idea. There were a lot of Great Basin and desert fires in recent weeks. It's been rainy, wet, stormy there, so the rain outweighed the lightning. We didn't get all those ignitions there. However, you can kind of see that the rest of the region is really active, and there is this ring of fire activity in the forested parts of the West right now. This would extend up into Canada if Watch Duty had a presence there, but alas, not yet. So I'm going to zoom into California first, Northern California, and show a few things. There's a few clusters of lightning fires. These lightning fires are mostly older. These are from last week or the week before, but they're still burning. Some of these are 10,000 acre fires and have evacuation orders. Then we have this cluster of lightning fires, which began, these are most of the ones that began on Tuesday, early in the morning hours from the true dry lightning events in the Central Valley and the foothills. And again, we're lucky that more of the lightning didn't occur in this region or in this region, or we would have had even more fires. This is the Garnet Fire, which is probably the biggest, baddest one in California right now, and it's continuing to burn aggressively in the wilderness, but not threatening too many communities. We then have another cluster of lightning fires here that we did a better job at extinguishing, possibly because there's more population centers along the Interstate 80 and Interstate 50 corridors. There's both better resource availability and more motivation to get those fires out because they're close to where people live. We then have this cluster of lightning fires that remains active. These are mostly of the holdover variety. So these occurred mostly during the wet thunderstorms last night. So smoldering tree stumps or dead and down snags, things like that. And so most of these are not doing too much. These are mostly small fires, but they're burning in more remote or heavy forested areas. And so these are ones that fire crews, again, these are sort of those fires I was talking about earlier. Some of them would probably go on to do a lot of good work if we let them burn for a while, but it's difficult to tell which of these would then end up blowing up and going on to threaten communities. So I'm going to zoom in now. The southernmost of the lightning fires is actually fairly large. It's now over 12,000 acres, and it's called the Salt Fire. And you can see there's active helicopters and air tankers trying to work on this one. And it's also, I've turned the satellite imagery on. It's got a lot of active fire pixels, so there's a lot of active heat on this fire still, especially on the more remote, more complex topography side and less on the grass fire side. So again, I'm guessing they probably have a cold line out on this side in the grass in a lot of places, but that's a lot harder to do up in the brush and trees in the mountains. So that's a pretty big fire. There are actually some evacuations with this that extend almost all the way north to Coalinga, but importantly, not to Coalinga. And I think at this point, the risk to Coalinga is near zero because there's not active fire on this flank, and you got to go through grasslands and then irrigated farmland to get to town. So in the absence of a very extreme wind event, that's not happening. So this one could burn for a while if it gets up into the wilderness up by Mine Mountain, for example. And you can see, it's an active fire if you look on the camera. But this is not hugely concerning. The Garnet Fire is probably now over 30,000 acres. It's in the wilderness, but it is very active. It's likely going to be burning for weeks to come. It's well up into the national forest, and you can see it's very active on 3 separate northern flanks. I don't really see any obvious opportunity to stop these flanks from continuing to do their move. I think the likelihood of spread in this direction, though, is pretty low at this point. Maybe not 0. So this fire really has room to run. And these directions constrained only by hitting the bare granite at higher elevations. So it will eventually run out of steam at some point in this direction, but it definitely could run quite a ways in that direction or this direction into the John Muir Wilderness too. There's a cluster of fires. There's still some evacuations. These are mainly grass fires, and there frankly is not much heat left on them. A few thousand acres of grass fires. Looks like these are largely getting wrapped up under current conditions. We go north. This, of course, is the series of fires that were most concerning and caused the structural loss yesterday. So we've got, in this case, right on Don Pedro Reservoir, the 6.5 fire and the 6.2 fire, which collectively have burned close to probably 10,000 acres at this point. So these are fairly large fires, and as you can see, these both still have active recent hotspots, so they are still burning actively. It looks like the segment of these fires closest to town, this is Chinese Camp, which unfortunately tells the story. You see that the official fire footprint, here's Chinese Camp, encompasses the whole town and a couple of surrounding areas. It does look like it spared the SPI timber mill, at least at last footprint, by the way. But this town, you can see the size of the town. Each of those circles is essentially a current street address. So you can see it's a very small community, but the number of permanent structures inhabited was on the order of dozens, and to my understanding, most or all of these were destroyed yesterday. There is an evacuation warning extending up close to Jamestown, but for now, under current conditions, I don't think there's really much of a threat remaining to Jamestown. There were other significant grass fires, by the way, in the valley. You probably didn't even hear about these, but they're multi-thousand acre grass fires. This one still looks a little active, but there were other grass fires as well in the valley, none of them super consequential. This is the 2.7 fire that threatened Murphy's, which again, there are still evacuation orders, but I'm not seeing much heat under current conditions. There's only one helicopter around. I think this one is probably getting pretty wrapped up. It's near the Columbia Air Base, so had that working for it, going in its favor. Other grass fires started by lightning, the Michigan fire, the Brown fire, the Rock fire. These are all fires that are long since extinguished. And then we get up into the holdover territory. So these are all fires, and you can see there's helicopters doing bucket work on a lot of these. But there are a fair number of them. There's probably, most of these weren't here this morning. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So there's like 2+ dozen just in this region. And these are still active holdovers. And there will probably be more to pop up in the hours and days to come. The Granite Fire gave people a bit of a scare last night. As I mentioned, it's just upwind of Paradise on a downslope wind day. There are some minor evacuations still, but this one looks like it's getting wrapped up. It had some potential to do some ugly things in a major wind event, but fortunately we did not have that major wind event, and it looks like things are going all right. So I wouldn't be so concerned about that one. Would not be too surprised to see other holdovers pop up in this region, although a lot of this is in the footprint of the Dixie Fire, where the fuels are greatly reduced relatively recently. A few more holdovers, the 5 fire, the Knob Cone fire, and then we've got the existing mostly lightning fires, the Dillon fire, the Blue fire, the Log fire, the Peak fire, the Lick fire, and other fires. that are not new, and I won't focus on them too much today. We go up into Oregon. We see there are some very large fires. There's the Emigrant Fire, 30,000 acres, very active. We see there's some new fires. This one has some evacuations associated with it. The Marks Creek Fire. The big one we saw blowing up with the pyrocumulonimbus, by the way, is the Wildcat Fire, which is not that far from Mount Rainier. Not a huge fire. Last count, it was only 2,500 acres, but as you can see, it's burning in very dense forest in a remote area near apparently Bumping Lake. I'm not familiar with the region. But this is really remote, really dense forest, really high intensity fire, a lot of fuel to burn, a lot of carbon being released, even though it's not the biggest fire we've ever seen. Other major fires, the Labor Mountain Fire, Lower Sugarloaf Fire, looks really active. I think that's Central Washington, and some other fires as well. You can just see all the fires around. So that probably covers it from a watch duty perspective right now. Okay, so the thing I know a lot of people want to talk about, I'm going to run a little over an hour. I'm going to try and keep it to no more than 10 minutes over, so I'm going to go quickly, is the forecast to come. So here's what it looks like. This is back in time. This is back Sunday. We go into Monday, we see this weak little low that caused all the havoc. Again, it didn't do anything in San Francisco, but it wreaked some havoc in this part of California. Remember, we're going back in time. Now we're going forward in time. This was yesterday into last night. We see it moved inland. Now that little low I showed you, it's now over southwest Oregon, just as I showed on the satellite image, and it's dissipating. So we still have west coast ridging. It's still warmer than average in a lot of California and much warmer than average up in BC, but it's cooling down. And it's going to continue to cool down. In fact, by this weekend, that west coast ridge, especially over Northern California, is likely to be replaced by an offshore low of some strength or another. Southern California is still under some ridging, but Northern California, not inside the low axis necessarily, but in this southwest flow regime. You go a little bit forward, even further, so now this is 4 days out, we get towards Sunday, Monday. That low might actually make some progress moving inland near Northern California. So that's a notable signal in the ensemble average 1 week out for an early season low pressure system. So I'll talk a little bit about what impacts that might bring in a minute. That signal eventually fades, and yes, we probably will return toward western ridging once again as we get toward mid-September, consistent with the seasonal outlook. And that would include, once again, warmer temperatures by mid-September. But what happens in between? So we go from this weekend, of course, being very hot in California along the west coast. Yesterday was hot as well. And today has been hot in some places, but cooler in others as the change arrives. Now, that will be about the same. This is today. Warm this evening. But then we go into Thursday, Friday. We start to see some cooling in California. It's still really hot in the Pacific Northwest interior in BC, but California's starting to get cooler. And then we start seeing some pretty cool temperatures over the weekend into early next week. So cooler than average, centered right over California. This is a little bit easier to see if I take the 5-day view. So right now we're kind of above average inland, really hot in the Pacific Northwest, cooler along the coast. But as we go toward the weekend, we see some below average temperatures, even as we get into the weekend. And then as we get back toward mid-September, things start warming up again to above average. But the thing I really want to point out is this. If I go to, say, let's just look at the European model, and instead of the ensemble, let's actually look at the operational model, just for fun to get a clearer picture. When that low pressure system comes inland, there's a range of potential impacts from this. The first thing that's going to happen when the low is offshore is it's going to get fairly breezy over California. This could be a period of elevated fire activity, even though the winds will be out of the southwest. If we have timber fires burning in the Sierra from lightning holdovers in 3 or 4 days, they're going to get a pretty stiff southwest wind pushing them upslope. That's one reason why CAL FIRE is trying to get a handle on Forest Service before that happens. Won't be an extreme wind event, but 15 to 30, gusts to 40 miles an hour, that's strong enough to cause some problems in the upslope direction if there's still active fires burning in the drainages. But then, as it moves inland, it's going to actually produce a decent chance of some showers, which are looking likelier than not in this part of California, so up on the north coast and up by maybe Shasta, with a slight chance of some showers maybe down to the Interstate 80 corridor, and I'll show you that. There's really no chance of precipitation in Southern California, though, with this pattern. And then as we go forward in time, I've jumped the gun a little bit. The rain is less likely at this point, but early next week is when those showers would be most likely. So I misspoke. That wouldn't be this weekend. That's a little too early. That's when the wind would be. But the chance of showers would be more likely in some parts of Northern California, perhaps by Tuesday or Wednesday, before fading, and we get that return to ridging. If we look at the American model ensemble, we look at apples to apples normalized height comparison, we get the same general picture. We go from ridging to weak troughing, and then a pretty decent low signal over Northern California, that nice little trough, and then we probably go back to some form of diffuse ridging with warmer temperatures by the end. Actually, this model cycle hasn't finished yet, so let me go back to the older one. Yeah, that would be what it looked like toward the end. So in terms of precipitation, what are we thinking of? Well, I've pulled up the European model ensemble this is for Eureka, so the North Coast region. And I gotta say, that looks like a pretty high likelihood of some substantial wetting or more than wetting rainfall. Nothing until about the 8th, so we got a few more completely dry days, but right around the 8th or maybe the 9th is when the odds start to pick up considerably. And there's a pretty good shot of the far north coast getting half an inch or more of rain. That would do wonders up there for the fire season, of course, along the coastal strip. And there would probably be some precipitation across the northwestern mountains as well. So there's a growing chance of a wetting, quarter inch to half inch rainfall. And again, you can see there's a wide range of outcomes. There's a couple of outlying members that have like 4 inches of rain for Eureka, which seems pretty darn unlikely. But then there's also some members that have literally a trace. So you can find a wide range of potential outcomes, the average of which is over half an inch. I'd probably go the under on this, given the earliness of the season, although I also do think that it's more likely than not that we get a wetting rain up along the north coast between some form of this. But I'm going to take a tour. We go a little bit south. Here's what things look like at Sacramento. And this is even a little more interesting because the majority of ensemble members from the European model have either 0 or trace amounts of rain. So that's the most likely, the median outcome, if you will, is a trace or 0. But there are a handful of members that have a solid, half inch of rain in Sacramento. And in fact, most of it happens right in this window, as I mentioned, right around September 9th or 10th or so. So there's about a 20% chance, I would say, once you get down to the Interstate 80 corridor, of a wetting rain right around September 9th or 10th. So it's not trivial. Most likely outcome, 70-80%, is that there is either no rain or just some sprinkles that won't really affect fire season, but there's a 20% chance of something more than that in Sacramento. I say there's about a 70 or 80% chance of that, though, up along the north coast and the far northern mountains up in the Shasta region. So that will be meaningful up there. Pacific Northwest, by the way, has an almost guarantee of getting about a half inch of rain. I still don't think it's fire season ending up there because we actually saw an atmospheric river, unusually in August, that brought up to 2 inches of rain up there, and these fires roared back to life. Some of them managed to keep burning through the rain. But as we get closer to the autumn termination of fire season in the Pacific Northwest, I think that half inch of rain up north is going to do more good than it will further south, just given that they're closer to the real onset of their rainy season than we are in California. If I go a little bit farther south to LA, as you can see, according to the European model ensemble, there is a 0% chance of anything more than sprinkles in LA. So not looking at any rain to speak of at all in Southern California. There is a low but not negligible chance of some measurable rainfall in about 5 days as far south as about Sacramento in the Bay Area. So there's about a 20-25% chance of meaningful showers on the order of maybe a quarter inch or so. although the most likely outcome is sprinkles or nothing. And then we go far north coast, far northern mountain, there's actually a pretty good chance of measurable to a soaking rainfall. So that will help fire season up in the far north. It would in Central California if it makes it that far south, but that seems pretty unlikely at this point. And it won't do anything for Southern California because the rain is almost certainly not going to make it that far south. So as I mentioned, mixed bag, but overall not a terrible pattern for fire suppression or for fires to burn at a lower intensity in the meantime, doing some good. I do not foresee an end to fire season as a result of this event. I know there's some hyperbolic claims online that some people have like cherry-picked this ensemble member and pointed out that California is going to see a huge storm, and right now there's no indication of that, but there could be some good showers along the north coast, northern mountains that will meaningfully affect fire risk up there in a constructive way on existing fires and tamp down the risk of fires for at least a few more weeks, and that buys us then a few weeks to get another rain event, which would tamp it down a few more weeks, and then we get into the rainy season. Central California, it's unlikely to substantively affect fire season, but there is maybe a 10 or 20% chance that the very wettest members come to pass. That would be a little bit better. Southern California, good luck. No rain in sight, which is not unexpected for early September. It's really pretty early still. It does look like things are going to warm up and dry out again thereafter. So mid-September onward, don't assume fire season's over if you get some showers in about 5 days, but also, wouldn't it be nice to have some rain? All right, so what I'm going to do now is bring myself back on screen. I will run slightly longer than planned, but we'll try and answer just a few more questions now that may have popped up. Oh, I think I'm sharing the whole, let's see here. Let me just make sure that I'm sharing what I've intended to share. Yep, it's just me. All right, so final questions here. Marilyn asks if many folks, it's a little bit off topic for today, but I'll allow it. Folks would like to see the scientists' response to the Department of Energy or DOE denial of global warming report, as some have called it. Is the scientists' rebuttal report available? Yes, and I actually was not personally involved with this because I just wasn't able. There are only so many hours in the day. This evolved very quickly. So that report, which by all accounts is really comprehensive and excellent, led by my colleague Andrew Dessler, is now available. I don't have a direct link for it queued up right now, but it's pretty easy to find. There's news articles about it today, and it is, you can call it the climate scientist rebuttal to the DOE report. That's probably a good Google search term, and you'd find it pretty quickly. I can share it next time if folks are interested. Professor H asks if there's any wind concerns for the next week. Again, I mentioned nothing extreme, but we will get an episode of fairly decent southwesterly breezes in Northern California, in particular in the mountains, before any rain arrives. So whatever holdover lightning fires are going to get potentially a good run for a day or two, at least in the afternoons when the winds pick up. That's what I'm finding likely. CAL FIRE just posted apparently on Blue Sky that 110,000 lightning strikes occurred in August and sparked 534 lightning-caused fires, with only 1% growing beyond 10 acres. That sounds plausible to me, although there's probably a few hundred additional fires that aren't even counted in that tally because I don't think they've fully accounted for everything that's happened in the last couple of days yet. So just winding up the questions here. And as many folks have pointed out, in addition to the factors that I mentioned when I was talking about the multifactorial causes of the escalating wildfire crisis, and I do think it's fair to call it that. We're losing a lot of structures and a lot of people in these fires these days. Not so much this week, but in general, is the invasion by certain species into different ecological niches, which is definitely a problem. But it's not unrelated to questions of suppression of lightning-caused natural fires and indigenous and cultural burning, which, again, created the landscape that we have today, but now we've abruptly and discontinually altered those practices and those processes in a way that, in a lot of cases, fosters increased fire intensity or increased longevity or survivability of these invasive species. And often, it's those invasive plant species that are the newcomers after a fire, because they're ecological niche colonizers. They're early entrants into a newer post-fire ecosystem, and so, but the reverse can also be true. And with the relevant fire frequency that a particular ecosystem is adapted to, you can actually, in some settings, use prescribed fire as a tool to get rid of the not fire adaptive invasives and give a leg up to the native species that are actually fire adapted and so will survive the fire or have some regenerative capability following a fire that exceeds that of their invasive counterparts. So you can actually level the playing field in a way that allows the non-invasive plants in a particular system to have a fighting chance. So again, it's all complicated, and it's very difficult to talk in generalities. California has so many different ecosystems, so many different types of fire regimes, so many different plant species that it's difficult. And it's very easy to get oneself into trouble and get people very upset because your favorite ecosystem is the exception to these generalizations. And so it's to acknowledge that there truly are differences, and we can't talk about California as a monolith. We can't bin together the chaparral, the Jeffrey pines, the juniper, the sages, the grasslands. These all exist. The oak woodlands, the redwoods. These are all very different systems and have very different responses to fire. Very different preferred, if you will, fire frequencies and intensities. Very different fire histories, and also very different responses to climate change and other disruption. Okay, well, I think that's about it for the day. Stay safe out there, folks. If I probably won't have any more live streams this week because I do have other work I have put off in the meantime. But as always, if something unusual or unexpected happens, I'll be here. And for now, I'll plan on seeing folks in next week's TBD live stream. Hopefully by that point, it'll be cooler, and it might have even rained in a couple of spots up in far northern California. Hopefully those southwesterly winds this weekend don't cause any big blow-ups on these Sierra Nevada West Slope or northern mountain fires. They might, but we will have seen it coming. It won't catch us by surprise. It doesn't look too extreme, at least at this point. All right, see you all next time.